Hey guys, Mr. Backerberg here. In this video we're going to be running through the review for test number 7. In problem number 1 we're asked to sketch the angle 9 pi over 8 in standard position. So the first thing we have to figure out is where this angle would be located as far as our axes go. If we go straight to the left, that's an angle of pi, and what we should recognize is that 9/8 pi is a little bit bigger than 1 pi. So if we're going to sketch this angle out, we're going to rotate around a little bit past that pi angle, and our terminal side will be somewhere down here in the third quadrant. So there's our angle 9 pi over 8 approximated down in the third quadrant. Now for number 2, we're looking at that same 9 pi over 8 angle, and we're asked to find some coterminal angles for that. So remember, for coterminal angles, we're either going to add or subtract a rotation. So if we've got 9 pi over 8, and we want to find a positive coterminal angle, we're going to add 2 pi to this because 2 pi is one full rotation. Now, in order to add these together, we're going to need common denominators. So I'm going to put this 2 pi over 1, and then we'll have to multiply top and bottom by 8 to get that common denominator. So this will end up being 16 pi over 8, and then if we add those together, 9 pi plus 16 pi is 25 pi over 8. Now if we're doing the negative coterminal angle, instead of adding a 2 pi rotation, we're going to subtract a 2 pi rotation. Again, we're going to need common denominators, so I'm going to put this over 1, and just like up above, it'll end up being 16 pi over 8. And then if we subtract, 9 pi minus 16 pi is negative 7 pi, and on bottom we've got 8. On number 3, we're given an angle that's written out in degrees, minutes, seconds, and what we want to do is convert that over to a decimal. So I'm going to get my calculator ready to go. For this one, what we're going to do is we're just going to start typing the angle in the way it's written. So we've got negative 408 degrees. So we have to remember where that degree symbol is located, and on your calculator there's an angle option. So if I hit second apps, it'll bring up my angle menu, and the degree and the minutes symbols are in there. So I'm going to choose the degree, and then we've got 16 minutes. So I'm going to go second angle again, arrow down to the minutes option, and then we've also got 20 seconds. Now the seconds is located in a different spot, and it's right here above the plus sign. So I'm going to go alpha plus to get the seconds symbol in there, and then I just have to hit enter. So there is my angle converted over into a decimal degree. Number 4 is going the opposite direction. This time we're given an angle in a decimal degree, and we want to convert it over into degrees, minutes, and seconds. So I'm going to use my calculator again. Just like I did on the last one, I'm just going to start typing this angle in. So it's negative 37.58, and we want to convert that into degrees, minutes, seconds. So I'm going to go back into that angle option, so second apps, and if we arrow down to option number 4, okay, that arrow DMS means that it's going to take whatever angle you typed in and convert it into degrees, minutes, and seconds. So we hit enter, enter one more time. There's our angle converted over into degrees, minutes, and seconds. In number 5, we're looking at converting this 9 pi over 8 angle from radians into degrees. So we're going to take our 9 pi over 8. To convert this into a degree angle, what we're going to do is we're going to multiply by 180 over pi. Now one thing you might notice is that there's a pi on top and a pi on bottom of our fraction, so those things are going to cancel each other out. So if we start multiplying now, across the top is 1,620, and on bottom all we have left over is the 8. So now if we actually do this division, 1,620 divided by 8, we should get 202.5 degrees. Taking a look at number 6, we're going the opposite direction. We're given a degree angle. We want to convert that into a radian angle. So we've got 345 degrees. To convert this into radians, we're going to multiply by pi over 180. Now this 345 is technically over 1, so if we start multiplying these together, we end up with 345 pi over 180. And then what I would look to do is I would look to reduce this fraction down. So this will actually reduce down into 23 pi over 12. On number 7, we're told that we have a circle with a radius of 13 feet, and we've also got a central angle of 45 degrees. Based on that information, we want to find the arc length and the sector area for this circle. So the sector area formula says S equals R theta, but one thing that we have to remember is that this theta value, this angle, has to be a radian angle. So this 45 degrees isn't going to work for us. What we have to do is convert that over into radians. When we do that, we should get pi over 4. So now if we look at this arc length formula, R just means radius, so we're going to plug in the 13 there. Theta is our pi over 4 angle that we just found. So now I would just type this into my calculator. It does say to round to 3 decimal places, so this is going to be 10.210, and this is a length, so we should label our answer. We were measuring in feet, so 10.210 feet. Second part says we want to find the area of the sector intercepted by this angle. So that formula, A equals 1/2 R squared theta. Again, theta has to be a radian angle, so we're going to use this pi over 4 again. So we end up with 1/2 times 13 squared times pi over 4. Again, we're going to round to 3 decimal places when we type this into our calculator. I got 66.366. Again, this needs a label, so it's feet, but this is an area, so it's actually feet squared. On number 8, we're looking at using the unit circle to evaluate the 6 trig functions for the angle 11 pi over 6. If we look at our unit circle, the angle 11 pi over 6 has an ordered pair of root 3 over 2, comma, negative 1/2. So if we start evaluating our 6 trig functions, I'm going to start with the 3 basic ones. Sine of theta, sine of 11 pi over 6. Sine is always the y value, so this is going to be negative 1/2. Cosine is always the x value, so that's going to be our root 3 over 2. When we're doing the tangent, we have to be a little bit careful. Tangent is y divided by x, so we've got negative 1/2 divided by root 3 over 2. Now what I see going on with this fraction is each one of these says divided by 2. So on the top of our fraction and on the bottom of the fraction, we could multiply by 2 to get those things to cancel out. So then we get negative 1 over root 3. But then we have to rationalize this because we can't leave that square root on the bottom of the fraction. So if we multiply top and bottom by root 3, we end up getting negative root 3 over 3. Now those other 3 trig functions, those reciprocal functions, we've got the cosecant, the secant, and the cotangent. Cosecant is the reciprocal of the sine, so since we know the sine is negative 1/2, all we have to do is flip that fraction over, so we end up getting negative 2 for that one. Secant is the reciprocal of the cosine, so if we flip that fraction over, we get 2 over root 3, but again, we'll have to rationalize this by multiplying top and bottom by root 3, so we get 2 root 3 over 3. The cotangent is the reciprocal of the tangent, and I'm not going to look at the rationalized answer. I'm actually going to look at the step before, where when we simplified, we got negative 1 over root 3. If we flip that over, we'll end up getting root 3 over negative 1, which ends up being negative root 3 if we simplify that down. On number 9, we're given a right triangle to take a look at. We've got one leg as 5. The hypotenuse is 13. We could use the Pythagorean Theorem to figure out that the other side of this triangle has to be 12. Now we want to look at our 6 trig functions. So our angle theta is down in the bottom right-hand corner. So if we do the sine of angle theta, when we're looking at a right triangle, sine uses the opposite side and the hypotenuse. So it's going to be 5 over 13. For the cosine of angle theta, cosine uses adjacent side, so that 12 that we just found, over hypotenuse 13. The tangent uses the opposite side, which is 5, over the adjacent side, which is 12. So those are our 3 basic ones, and then we've got all of those reciprocal functions. For the cosecant, we want to take that sine fraction and flip it over, so we get 13 over 5. For the secant of theta, we're going to take our cosine and flip it over, so we get 13 over 12. And then for our cotangent, we take our tangent fraction and flip it over, so we get 12 over 5. Taking a look at number 10, we're told that the sine of angle theta is 3 over 7, and we want to use that to help us find the cosine and the tangent. Now, I think the best way to go about this would be to draw out a right triangle. I'm going to put theta down here in the bottom left-hand corner. There's our right angle. The sine of theta gives us the opposite side and the hypotenuse. So the opposite side has to be 3, the hypotenuse has to be 7. Now, if we use the Pythagorean Theorem to find our missing side, it ends up being 2 root 10 once we simplify down that radical. So now if we're looking at doing the cosine of angle theta, cosine is the adjacent side, so that 2 root 10 over the hypotenuse of 7. For the tangent of theta, tangent is opposite over adjacent, so we get 3 over 2 root 10, but we can't leave that root 10 on the bottom of our fraction. So we have to rationalize this. So across the top, we end up with 3 root 10. On bottom, root 10 times root 10 is a regular 10, but then we also have that 2 there, so 2 times 10 ends up being 20. So we get 3 root 10 over 20. On number 15, we're told that we've got a wire running from the ground up to the top of a 30-foot telephone pole. So what I would do is, I would draw out a picture to represent this. So we've got a right triangle that looks something like this. This vertical side is going to represent our telephone pole, and we're told that's 30 feet tall. Next piece says the angle between the wire and the ground is 57 degrees. So the wire is this diagonal piece. The ground is the flat horizontal piece. So the angle between them is going to be 57 degrees. And what we want to do is we want to figure out how far away from the telephone pole is this wire attached. So we're looking for that horizontal distance across the ground. Now if we look at how this is set up, we've got the 57 down at the bottom left-hand corner. 30 is opposite and x is adjacent. Since we're dealing with opposite and adjacent, we're going to use the tangent of our 57 degree angle, and that's got to equal 30 over x. Now what I would do is I would put this tangent over 1 and then do some cross multiplying. So 30 times 1 is 30 equals x times the tangent of 57 degrees. Now, in order to get x all by itself, we have to divide both sides by the tangent of 57. So on the left-hand side, we're going to take 30 divided by the tangent of 57. Now, since this is a degree angle, when you're typing this into your calculator, we need to make sure that we're in degree mode. When we type this in, I'm going to go just to one decimal place. We end up getting about 19.5 feet as our x value. In problem number 12, we want to take the left-hand side of this equation and use some trig identities to convert it over into the right-hand side. So I guess what I see happening on the left-hand side is I see a binomial times another binomial. So in order to multiply this out, we're going to end up foiling. So 1 times 1 is 1. If we take 1 times negative cosine, we're going to get minus cosine of theta. In the middle here, cosine times 1 is a positive cosine of theta. And then if we take cosine times negative cosine, that's going to be negative cosine squared theta. Now in the middle, we've got some terms that are opposites of each other, so those are going to cancel each other out. So we get 1 minus cosine squared of theta on the left-hand side. And I guess let me copy it on the right-hand side. We've got sine squared of theta. Now if we look at using the identities, on the left-hand side, I see this cosine squared. So I'm looking at our Pythagorean identities. And this is one of those alternate forms that I had you write down, 1 minus the cosine squared. That is the exact same thing as the sine squared. So we can replace that whole left-hand side with the sine squared, and then this equals the sine squared. And that's what we were going for. We wanted to get the left side to match up with the right side, so we're done on this one. On number 13, we're given the angle 2 pi over 3, and what we want to do is sketch that out and find its reference angle. So 2 pi over 3, well, remember this angle over here is pi, so 2 pi over 3 is a little bit less than pi, so that angle would take us over here into that second quadrant. Now the reference angle is the small acute angle that's formed between the terminal side of our angle and the nearest x-axis, so for us that'd be pi. So if this is 2 pi over 3, we got to figure out how big does this small angle have to be between our angle and pi. So the way I would do it is I would take pi and subtract off 2 pi over 3. Now we're going to need common denominators over here, so this pi is going to turn into 3 pi over 3. And if we actually do that subtraction, 3 pi minus 2 pi is just pi, and the denominator stays as 3. 14 is very, very similar, except we're given an angle in degrees. 309 degrees is maybe a little bit easier to see where that would be. That would take us around almost all the way. So we end up with this being our 309 degree angle. So if we're looking at the reference angle, it's this small acute angle in here. A full circle would be 360 degrees. So to figure out how big that little angle would be, I would take 360 degrees minus that 309. And when we do that, we should end up getting a 51 degree reference angle. For the last one, we're given the point -5, 2, and we're told that's on the terminal side of our angle theta, and what we want to do is figure out the values of our 6 trig functions. So I think how I would go about doing this one is sketching a picture. We've got the point -5, 2, so we have to go left 5 spaces, up 2 spaces, so our point ends up being up there. I'm going to use this to complete a right triangle. Across the bottom, we went -5, we went left 5 spaces, and then going up vertically, we went up 2 spaces. Now if we're going to do the Pythagorean Theorem to find our missing side, that ends up being the square root of 29. Now theta we always put right next to the origin, so it's going to be this angle down in the bottom right hand corner of our triangle. And now that we have this right triangle, it should be fairly easy for us to do the 6 trig functions. So if we're going to do the sine of theta, that is the opposite side over the hypotenuse, and we'll have to rationalize this, so we end up getting 2 root 29 over 29. For the cosine, that's going to be the adjacent side over the hypotenuse, so -5 over root 29, and rationalize that to get -5 root 29 over 29. And then for the tangent of theta, we go opposite side over adjacent side to get -2/5. Then if we start doing all of those reciprocal functions, the cosecant is the reciprocal of the sine, so we've got root 29 over 2. The secant is the reciprocal of the cosine, so we get root 29 over -5. And the cotangent is the reciprocal of the tangent, so we get -5 over 2. That's going to be it for this video. Thanks for watching.